Hello, everyone, and welcome to the stream. My name is Jared. You can call me Jardo if you want. And we are back for day 6 of the Advent of Code 2024 in Ruby. We are doing it. The goal today, though plans may change as we see the problem, is to just do as much as we can with method missing. And I've kind of got some ideas in my head on what we could do to make a really obtuse solution using method missing. But remains to be seen. Well, as I was just saying before I started recording, I also want to find one of these if one of these problems is parsable as Ruby, then I want to find a way to just eval it and get the solution. And I've got some strategies in my head for how we might do that, but it's sort of a pivot we'll make if we run into an input that I think it's conceivably possible to do that for. We're going to do that. But without further ado, let's get into day 6 here. The historians use their fancy device again. This time to whisk you all away to the North Pole prototype. The North Pole prototype suit manufacturing lab in the year 1518, which looks like these are probably references to previous puzzles. It turns out that having direct access to history is very convenient for a group of historians. You still have to be careful of time paradoxes, and so it will be important to avoid anyone from 1518 while the historians search for the chief. Unfortunately, a single guard is patrolling this part of the lab. Maybe you can work out where the guard will go ahead of time so the historians can search safely. You start by making a map, your puzzle input of this situation, for example. Now, unfortunately, that does not look like parsable. That does not look parsable as Ruby to me. So today is not eval the input day. The map shows the current position of the guard with a caret to indicate the guard is currently facing up from the perspective of the map. Any obstructions, crates, desks, alchemical reactors, etc. are shown as pound or hash symbols, or octothorpes if you so prefer. Lab guards in 1518 follow a very strict patrol protocol which involves repeatedly following these steps. If there is something directly in front of you, turn right 90 degrees. Otherwise, take a step forward. Following the above protocol, the guard moves up several times until she reaches an obstacle, in this case a pile of failed suit prototypes. Because there is now an obstacle in front of the guard, she turns right before continuing straight in her new facing direction. Reaching another obstacle, a spool of several very long polymers, she turns right again and continues downward. This process continues for a while, but the guard eventually leaves the mapped area after walking past a tank of universal solvent. By predicting the guard's route, you can determine which specific positions in the lab will be the patrol path, including the guard's starting position. The positions visited by the guard before leaving the area are marked with an X. In this example, the guard will visit 41 distinct positions on your map. Predict the path of the guard. How many distinct positions will the guard visit before leaving the mapped area? Okay, and so let's take a look at our input. We're playing a roguelike again today. All right, and somewhere in here there's a caret. I don't see it. There it is. It'd be funny if it just like took a beeline to the top and we could just do this one by reading it. Sadly, no, I suspect their inputs do not allow for such possibilities. All right, so I have put the Advent of Code solutions that I have so far for 2024 up on my GitHub. There are links to them from the blog post, but github.com/JaredNorman/Advent of Code 2024. No hyphens like there are here. There's just Advent of Code 2024 if you want to go check that out. But we'll copy our template to day6.rb. And we'll touch day6.txt, and then we'll copy this into it. And then we'll start thinking about what we want to do. Now we said class eval. And I don't really know how to do that because it's going to be pretty contrived for this one, but we can do that. Parsing this data isn't super hard. I was just thinking if you could do something with range. Oh yeah, to eval it. Yeah, but the hashes don't really, they kind of ruin it. And you would need even, like, yeah, there's no, I like the thinking. That also occurred to me, but I can't see a way of making it work. What constitutes a valid method name? Can you send any symbol? I know you can't. There are rules, like if I do that, it's not gonna work. Can I like send? No, it doesn't like that. Can send any symbol, yeah, but that doesn't even work. I would have to put it in a quote, which I can do. An defend method. So yeah, I'm just you know, let's explore here. So we can name a method hash. Can we make, so that's pretty funny. What about a dot? Yeah. Okay, that's interesting. This intrigues me. What do we want to do? Guess you'd have to map each character to a compatible symbol. Well, it looks like all of our, yeah. Oh, that's that one. Yeah, these all like work as terrible method names. Well, that's, yeah, we can't eval the input still because it's still not valid Ruby. And can I define method? I define method as a number. Okay, so we can send. Okay. Some other Jared liked the post that we're going live. A 2R Jared. Oh, hello, Sam. Welcome to the chat. We are just trying to figure out what terrible things we can do. So I'm thinking of loading the data into the into a map object by just sending values at the object. and using method missing with a case statement or something. That's what I'm thinking right now. Oops, that's what I meant to do. I meant to do that. Okay. All right, let's see if we can do that. Let's see. We'll use class eval to load this in like the worst possible way. So we can make a map, and I want to basically be able to say map equals map.new or even input.lines. How do I do this? Yeah, I can do it with lines. Input.lines with inject. Inject's a silly way to do this. And remember that the memo goes first, and the line will be second. We always want to return, and then for each line, so I'm just trying to like write out the code that I want to make work, and then we'll try and figure out a way to make it work. Probably want to just map these through strip to get those new lines off of there. And then line dot chars dot inject map with the map and file that read lines. Yeah, I guess so. Maybe I'll update my template in future to do that. Now, do I need to? Can I just? I was using symbols. Does send accept strings as well? Is that fine? It does. Okay. Well, that's convenient. And I'm thinking maybe map dot, having something called a map is funny. Good to know. Good to know, Marco. And so I'm imagining that the methods all return an updated map. And or mutate the map and return it. We don't really need to do that, but I don't know. Why not? And then we can call end of line here after each line to, or maybe we call new line before. All right. And like I said, I think we should define all of the logic inside of method missing. What are the arguments to method missing? I guess it's the name of the method. Let's go look up the docs for that. Haven't actually written a method missing in, this isn't the docs, but it'll tell me the answer. Sure. Noel Rappin's got a good one. This is interesting. I wonder where the like legit docs are for this. We don't need the block. We're not calling it with the block. We're also not calling it with an args currently. And if there is one thing that is true so far in our solutions, it is that we are not covering edge cases unless we absolutely have to. There was a lot of that in day 5, where we just ignored technically things that we should have done in order to make this happen. So I'm just going to binding.break here and make sure that we like get to the point that we would expect to. All right, we're in there. Method name, is it going to be a symbol? Yes, it's going to be a symbol. And so we can start building our case statement around method name here. And let's put an else clause in here where we actually like raise, we forgot something. What? Uh-oh. Oh, I did. Do I need at least one when? We forgot something. Method name. Let's do that. We forgot. Oh, okay. So that's us getting as far as invoking the first character of this file on it, which is actually kind of cool because it shows us that that is a symbol, and so we can even put that in here as a symbol. And I just want to get this code running, and then I'll get it doing the right thing. So let's see what the next one is. Undefined method dot for nil. Okay, and so that's because this isn't actually, this needs to return self here. And then we need to hash. We can just put that on the end here for now, because we know that we will need to split these out, but amazing. Okay, and that just prints the input, which is definitely not the solution, but that gets this code running. So I think every time we call new line, first we'll have to make sure that the line's instance variable is initialized. So we'll make like an array of arrays here. This is not a way that makes any sense to actually. Oh, how do we want to store this? I was going to do an array of arrays, but then this code just becomes like the most absurdly obfuscated parsing we could possibly do. What if we keep all of the obstacles in a hash where the keys are their coordinates? And then in here we say like, oh, the current pointer starts at and this is more of like this is where we're reading first. And we set the x to 0 every time we hit we're always setting x to 0 when we hit a new line, and we're incrementing y. So this actually is -1. We can do this as at y or -1 plus 1. So that'll be 0 on the first run, and it will increment on subsequent runs. Okay, now I see a solution coming together, I guess, kind of. And now we know when we call each one of these, we know that, let's split them all out. We already know that dot is a no op, which is fine. We return self. Ooh, what did I just do? I do not know what I just hit. Caret needs to store where our current, like store the current pointer as where we are. Maybe we just do nothing here, and we always return self from method missing. Because we always need to increment the pointer. So we also have this other logic where we want to say at x equals x plus 1, at x plus 1, and but we don't want to increment y. Y is incremented the other time. So this doesn't do anything. Correct, and then we just increment x. We identify there's nothing at that position. The pound symbol, we need to mark that as a as having something in it. So we say, oh, give me our obstacles hash needs to exist if it's not already created. In case, I guess I haven't made this explicit, I am trying to write all of the solution, like all of our code in any custom classes we write inside of method missing. We're not even, we may add other private methods to call or something, but currently I'm thinking we just put the entire solution inside of a method missing. So this now becomes at obstacles, and then we want to set the key that's equal to at x at y to be, we can just make it true for now. And guard x, we can say guard position, I guess, equals at x at y. Okay, this kind of looks like something, and if it works, then the map that we end up on the other side should contain all of the coordinates of all of the things. Yeah. And I guess the other thing we want to know is what the bounds are, right? And there's different ways I can think of doing that, but there are obstacles on all of the edges, so we can just look at the maximum, minimum x and y values currently. Well, minimum is, it's gonna be 0, and we can just look at the maximum. Well, don't know where I'm going there. So now we actually have to think about how we solve this problem. We could do something like, do you even need inject? No. We don't need inject. It's not really adding anything. I think it's kind of, I thought it would be kind of funny to use inject, but that is a good point. We don't technically need it. I had like played with the idea of making the map an immutable object. That returns like an updated one, but that's not necessary. All right, well let's we can remove the inject. It's really not adding anything. Because we can then just make this a plain old each. Remove that. Make this a plain old each. Remove that. That'll do the same thing. Our map still should end up just like we had before. The coordinates are in there. And so the question is, what do we do now? I guess this x+1 only really needs to happen in these cases. Oh, it shouldn't happen in this one. Interesting. So we were actually getting it. We had a bug because of that. So there you go. Perfect. All right. So that's, we fixed a bug. Did I remove the binding.break? I did. Double check that that's still working. Lovely. Cool. And that makes sense. That leaves our x and y at the expected values. Should be the bounds of this thing should be 129 and 129. That should be the final column, and the pointer is pointing off the end, which is expected. Or calling that thing a pointer, I don't know. That's probably not the right word to call it, but that's fine. Ooh, hello, other people. Hello, Carl, and all of you other people that have joined the chat. We are making a giant method missing. So now that we've got this functioning, we need to step through until the guard goes off the board. So, I mean, it's like while map dot guard on board, map dot step or something. I don't really have a silly dynamic thing to call here. So I guess we'll just go with that. So now we can implement, so I'm going to say when guard on board and when step. Oh, we need to know the direction the guard is going to. We only call this once though, so we can say guard direction equals up. And we can handle that as cases as we go. So guard on board, we can say guard position first is, or I guess, let's say guard all, and we want 0 to 129 to cover each coordinate. That doesn't handle boards of varying sizes. It just covers our input, but that's fine. That's fine for now. And then we need to figure out what step does. So case guard. So we will operate on the guard direction and figure out what we need to do in each case. But let's start with up. And then we'll just raise an error if we forgot something. So we want to look at the position above and check that it's clear. And so we can say if obstacles guard position first and guard position dot last -1. That means there's an obstacle there, otherwise there's not. If there is an obstacle there, then we want to turn right. So we set guard direction equal to right. And otherwise we just move to this position. So we can even say new position equals new position, and if it's clear, then we say guard position is new position. That seems reasonable to me. So this should err until our guard, or this should work until our guard hits up, or like hits an obstacle going up. We didn't implement right, so it did it. We can do the same thing for right now. Now we're not recording the positions yet. I'm aware of that. We could even method missing operator overrides if we want. Like we could take away these names and make them like unary operators. We're not doing that yet though. We'll think about that later. So we say, okay, the next position if we are going to the right is to increment the x coordinate. So that's that. If we find that there is an obstacle in our way, we now want to go down, otherwise we continue on. Amazing, that appears to have worked. When down, we can implement now, and going down is incrementing the y coordinate, which I know is a little counterintuitive, but and if we hit something, we go left. And so this should step us, and we haven't implemented left yet, so looks like that code all worked. And so in this case, going left means decrementing the x coordinate, and if we hit something, we want to go up. And that runs. Which is bizarre because I wouldn't expect it to, because we didn't we did implement guard on board. Okay, so that's great. So this is progress. It's coming along. So we just need to record those positions as we move. Every time we step, we want to record the current position because we need the starting position in there. So we'll say guard positions equals, we want this to be a set because we don't want duplicates in it. If guard passes over a coordinate that they've already passed over, we don't want to record a new location. And I was almost going to use a hash, but set is basically the same thing here. So in fact, we could have used a set for the obstacles too. Anyway, that's fine. We should have done that. Guard positions. So we want to record the new guard position, or the current guard position. And then what are we actually looking for in the end? It was the number of distinct positions. Okay. So then we want to say at the end, we want to say map.positions or something. And this, or position count maybe is a guard position count. And this is guard positions dot size. Size comes from enumerable. I'm actually curious. Do size and count do the same thing? I know I accidentally used one of them. Alias is length. The wrong one in one puzzle one year, and I was iterating over all of the elements in some collection rather than just using the size of it. Does this seem reasonable? You think that works? No. Because we didn't change this. This is guard position count. It's a lot of positions. Is it the right answer? It is. All right. So we've managed to get almost all of our code inside of method missing, except for this short little bit here. That's pretty terrible. We were calling methods that cannot be invoked naturally. Thank you, Marco. Because those are not syntactically valid method names, even if you're allowed to use send for them. Don't like that the method missing is inside the map class and not in the global namespace. I mean, I could. It's just a bunch of instance variables. Let's take a look. Let's think about that. Let's think about that. So you're suggesting that I remove our custom class entirely, and we just call these methods. I like it. I like that a lot. That's a very good suggestion. Oh. Redefining object method missing may cause infinite loop. Something else is defined. Oh, come on. Do we need to refine it? I want to make this work. I like this idea too much. Oh, do you have to return self? Where from what? From the method missing? We're not using the return value anywhere. We're getting a wrong number of arguments, which suggests to me that something else is using method missing. So maybe we need to, so we can get rid of this else, we're never hitting that. Maybe we need to super. If it's not one of ours, there we go. Yes. Okay. We probably could have made that work with refinements as well, but I think something else is depending on method missing somewhere, and so we don't want to interfere with whatever that other method missing is doing. Lovely. This is very funny. In fact, we could even move input inside of this. In fact, we could move it all inside of this. Can't we? Can't we just be like part one? Like if we move all of that inside of here. Yeah, there we go. The whole problem is now inside of the method missing. All right, this is getting good. All right, let's commit that and take a look at part two. Thank you for that suggestion to get rid of the map class, because this makes this so much better. While the historians begin working around the guard's patrol route, you borrow their fancy device and step outside the lab. From the safety of a supply closet, you time travel through the last few months and record the nightly status of the lab's guard post on the walls of the closet. Returning after what seems like only a few seconds to the historians, they explain that the guard's patrol area is simply too large for them to safely search the lab without getting caught. Fortunately, they are pretty sure that adding a single new obstruction won't cause a time paradox. They'd like to place the new obstruction in such a way that the guard will get stuck in a loop, making the rest of the lab safe to search. To have the lowest chance of creating a time paradox, the historians would like to know all of the possible positions for such an obstruction. The new obstruction can't be placed at the guard's starting position. The guard is there right now and would notice. Yes, of course they would. In the above example, there are only 6 different positions where a new obstruction would cause the guard to get stuck in a loop. The diagrams of these 6 situations use 0 to mark the new obstruction, pipe to show a position where the guard moves up, down, hyphen to show the position where the guard moves left, right, and plus to show the position where the guard moves both up, down, and left, right. Option 1, put a printing press next to the guard's starting position. Option 2, okay, so it shows some examples. Thank you, Oynak. We are doing our best to honor his memory. It doesn't really matter what you choose to use as an obstacle, so as long as you and the historians can put it into position without the guard noticing. The important thing is having enough options that you can find one that minimizes time paradoxes. And in this example, there are 6 different positions you could choose. You need to get the guard stuck in a loop by adding a single new obstruction. How many different positions could you choose for this obstruction? Okay, so I'm just thinking about that one, this one. this is pretty doable. In my mind, I'm going to put the same harness that I put on before. So I'm going to say we want to just make sure, say results equals part 1, raise part 1, whatever I want to say, was part 1 changed, part 1 changed, unless results is 44656, and then puts results, and then we can also put part 2. So part 2 is going to have to be when part 2 so yeah, I mean, I have done that previous years, ONAC. That's a totally valid way to do it. If that's, there's lots of ways to do these puzzles and lots of reasons to do them, and we're doing them for evil. But practicing your mini test is a totally valid one too. There are also lots of ways to not do them, yes. So 130 times 130 isn't that big of a number. 17,000. So we can check all of the positions that don't already have an obstacle in them and see if they create a time paradox. The thing is that our recording of the guard's position as it moves through now needs to be able to determine if the we need to store which direction the user or the guard was going. Do not need to check positions that are part of the original path. That's true. That's true. Or no, we still do, because placing an obstacle somewhere in the original path might turn it into a loop. In fact, we only need to check the positions that are part of the original path, because otherwise he won't run into them, or she won't run into them. I think it was a woman there. Yeah, only on the original path. So our guard only runs into them if they're on the original path. So actually pulling those obstacles out gets us are what we need to iterate over. But we need to ignore the first one, whatever the first one is. Okay, so part of this is we need to now record the direction that the guard was going as they passed any given position, because if once they go a direction, the same direction in the same position, that means they're in a loop. So let's just work on part 1 and get part 1 working, recording those as the guard moves, and then we can come back and do a little bit of work to try and make this works. So in these, we now want to record a third piece of information, which is the guard direction. So each of these is going to change. But that means we need to also change this, because we need to, this guard positions now is going to contain duplicates as the guard passes through intersections. And so we need to map this to only the first two. First two. Set. Yeah, it is a set, but now that the guard direction is in there, we're going to have duplicates, right? So we need to take that into consideration. The one thing we start, never mind, that doesn't matter. So that is probably still the right solution, I think. If map, does map on a set return a set? Does anyone know the answer to that? How do I create a set? Do I have to require it? No, I shouldn't have. Oh, I have to require it. Require set. There we go. And no, it returns an array. Okay. And but I can call to set on it. Lovely. I also could have just called unique. Those would be indistinguishable, wouldn't they? Part 1 changed to result. Change to 1. What? What did I do wrong? Guard positions. Oh, I know what the problem is. Set.include is O1, array.include RON. Yep, that's correct. Our check now needs to be fixed because guard on board it should be first two because those are the coordinates. Minus for an instance of symbol. Uh-oh. I love this warning. Redefining method missing may cause infinite loop. Yes, it may. This is line 77 that we've run into an issue. Oh no. I don't like that. Oh, I can't do that here. What is? Oh, this is gonna make this really hard to debug. Yeah, oh yeah, I have to begin. Thank you. Oh, it doesn't like that at all. It seems to. So let's try and think here. Undefined method minus for an instance of symbol. That seems to be not in our code. That's upsetting. Oh, that's these ones. These are not right. This needs to be the similar bug to what we just encountered. Didn't it say line 31? Yeah. Oh, it did it. Yeah. Well, there you go. Thank you, everyone. Okay. So now we are recording the positions, and it works. Let's commit. I feel like we may get ourselves into debugging hell. So let's continue to record positions of, or record directions of the guard as she moves. All right. Next step is, can I write this as this? Does that work? Just try to clean this up a little bit. Make it more beautiful, you know? Oh. Cool. All right, that's a little cleaner. For the it in blocks on 3.4, yeah. I've tried to use it a bunch of times already. Let's say when guard positions, let's change this to plural, guard positions count. Okay, that should still work. Part 2 is printing nothing. So we need to do part 2. We're iterating over guard positions, which will have already been created. But we want to reset things. Right? So this is going to be like a count where we iterate over the XY coordinates. And in here we return true or false if placing a if placing an obstacle there makes an infinite loop, and we need to also remove the guard's initial position here. Right? I started doing copies of the map with the new obstacle added, but horrible idea, ended up storing the obstacle position on each loop and adding that to the obstacle condition. So let's make it so we can just sort of reset the board to its initial state, which is this code, right? initial position. Okay, so that's just erroring because of this code, this pseudocode I wrote here. Ignore that. Okay, so we're still getting the right solution now, but we can reset the board. So we'll, but that doesn't reset everything. That doesn't reset our obstacles. No, but we don't want it. Well, we do want it to reset our obstacles. We do want to reset our other stuff. So this maybe goes in here and reset board. And resetting board will naturally reset the guard's position when it parses that, so that's fine. But we need to reset the, we need to do this as well, because the y is not going to have been reset. So we'll have to also reset y to nil here. Okay, that seems good. And we'll also want to reset the guard positions, right? Guard positions, I don't even know where those get set. Guard positions, oh, we or equals it here. So we want to nil it out here. Cool. So that seems like a pretty reasonable reset board. Double check that we haven't busted anything. Yeah, it's still working. And in this situation, we want to save our gold guard positions. Original guard positions equals at guard positions before we reset the board. And then we want to reset the board. And then we want to iterate over. Oh, these ones contain the these are positions that contain directions as well. We don't actually need those, so I'm going to remove them. And then so we want to iterate over original guard positions here and remove having removed the initial position, which is stored in at guard position. Oh, interesting. We were storing it as a separate variable. Interesting. Maybe we should fix that as well, because this, we could just do that. This becomes guard position first two. Something like that. I like that. I like that. Oh man. So, and then we can actually update all of this code. No, we don't need to. This is just how it worked before. We just hadn't updated that because it didn't break anything. And this just becomes guard position last. Just using as an array as a thing is kind of shitty. But I don't know. We would have to put part of this the solution outside of the method missing if we wanted to introduce like a new object. I guess we could make it a hash, but I'm not gonna do that. So this should print 0 if we no, it loops forever. Where is it looping inside of? Data RB22 and then 74. Uh-oh. We have introduced a bug. And then 90. Yeah. Okay. So we're just stepping forever now. Well, that's unfortunate. Do we miss a reference to guard direction? Oh, we're not changing it. Oh, interesting. Right, because you're going to hit. Right, okay, so that makes sense. We're not, we're just getting stuck. That's fine. These just need to be updated to change this so it's just the current position. It's guard position first 2 and then that, and this is the new guard position. Just happened. Oh, I see. So that's just my editor trying to be smart for me. This will be the same but down. That'll pop snap into position. Be the same but left. And this will be the same but up. Spacing in here to try and make this ever so slightly easier to read. No, we're still infinite looping. Dang. Why would that be? So that handles the turning properly. We're now so what have we changed? Guard on board. No, we updated guard on board already. I don't think that affects it, but let me take a look just to see. So guard on board is still going to look at guard position. It's only going to look at the first 2 elements and make sure that they're within bounds. And we can, as an exercise, print the first 2, and that'll probably tell us something. So that's a good idea. Can I just print that? So we are getting stuck at 8135. In fact, let's print the whole thing. Why are we just printing the first 2? We need that information. We are getting a nil direction. How is that possible? Oh, and because we were using guard direction before. Well, there you go. Perfect. So this is just gonna stay. We're just continuing in the same direction in these cases. Oh, that's yeah, that's right. And then this is up. Okay. Undefined local variable guard position for main. On line 33. What did I do on line 33? Guard position. So that's just missing. That. Ta-da! Okay, so we're back. We're back in business. That was a little trickier of a refactor, mostly just because of this obtuse code that we've written. But thank you, Oynak, for pointing us at a debugging path there. So now we're here, and we are actually iterating over what is probably, just double check it here, but that's probably the list of, yeah, and then it's going to head off the map. Okay, that sounds good. We don't want to, each time we iterate, so we're going to want to put an obstacle at that location. So we're going to test putting an obstacle at that location. And then we want to do something like this. We want to step while the guard is on the board, and how do we want to write this? Because we want to step until we loop, or the guard leaves the board. But we need to differentiate them, right? If the guard leaves the board, that's a failure. That's a false. So we can do a little loop-de-doo, here. So we can do step if not guard on board. One of the funny things about this is we've got I've got Ruby LSP running, but because we've defined all of this inside of a method missing, I don't get method completion for anything we've done here. So if not guard on board, we want to next false. Else if looping, we want to next true. And then, oh, we need to reset this before each one of these. So we actually need to reset this up here. Oh, we need to reset in both spots because we need the original guard position. That's funny. So we do almost unnecessary reset board there, but not break. It's definitely next because we're counting here. Or wait, no, is next going to do the loop? I was thinking about the call to count. Maybe you're right. Maybe that is break. Good call. Good call. Thank you. Because we want to break out of this loop, not next this count up here. Block, or yeah, the block to it. Okay, all right. So this all exists, this all exists, this all exists. It is simply looping that does not exist. And that means that when we add our positions to the guard positions here, we need to set a flag so that we can identify that we have looped. So for starters, we should set that here. We should say looped equals, or looping, I don't want to call it loop. Looping equals false. And here we want to say if guard positions include the new guard, or the current guard position, and that includes the direction we're going, then looping is true. Otherwise, toss it in there. And then I guess we could just say, let's define a looping. Why not? What's another case in this? This is not working. So let's take a look at where it completes day one, but then we end up in an infinite loop here. Give it about 2 minutes. Do we think we're not in an infinite loop? There's not that many options to try. So let's step through. If you're right, it's pretty easy to check. We can just put x, y, inspect here, and see if we're actually moving through them all. And we are. It's just taken a while. Good call. All right, let's see if that's the right answer. No, that does seem too high. Yeah, but unfortunately we didn't get the right answer. It's warned us that is too high of a number, which makes sense. For how much too high? So what's the size of this? So yeah, this is suggesting that there are $4,908. Are you turning twice when you have obstacles in front of you to your right? And to your right? I don't think so. For what? Down and upright. I mean, I see normal amounts of turning here. If we're going up, we turn right. If we're going right, we turn down. If we're going down, we hit an obstacle, we turn left. How do we debug this? Why are we... Maybe we should examine this situation. Going up is obstacle. Are you going up? Up is obstacle. You turn right, but right is obstacle 2. And you move directly. As I understand it in... Let's see, are there situations where that could happen in the input? Probably. Yeah, so like hypothetically, if you... well, these ones don't actually allow that. But probably as a spot. Yeah, maybe if you're coming down here, turned and hit this. But I think our logic handles that. Yeah, because we don't this solution, when you hit an obstacle, you don't advance. So these that's what these cases are. And so this says like, oh, if you're in this, if the next position that we would go to if we're traveling up is here, if it contains an obstacle, then now we are still in the same position we were in, but we're going right now. And on the next pass, we would check that position. To me, it only happened with the added obstacle. Yeah, it would happen a lot with the added obstacle. You're right. So if you had that bug, you would hit it you would like guaranteed hit it because you'd be adding obstacles along the path that you're traveling. And so you're guaranteed to have that situation. But I think we've handled it here. This is one situation where like I've always thought about doing these maybe in the browser or something, and then having a like in order to have a nice visualization tool at my disposal. I know a lot of people do that. Be kind of fun. I might do that in a future year or something. So I guess the question is, we're hitting loops frequently when, like way too frequently. Yeah, they are a lot of work. That also so is just like thinking really hard to debug this. So this, it's gone through a whole bunch of them. And before it's even hit one that looped. I don't really know that I'm gonna be able to get much from, manually examining this. Let's see, continue. I'm just trying to. That was like instantaneous. Why are we still moving? Why are we still in a step? So this is suggesting at 103.58 or 103.57 and 103.58 and 103.59 we're all hitting loops. This is suspicious because that's probably not true. So 103 is 104. Try to see on the board what that would mean. So let's see, make sure I'm doing this right. I believe that is this character. This seems wrong. This seems busted. What the heck? Because there would be no way that just coincidentally this would happen. One of 361, 1 of 362, 1 of 363. Something is definitely wrong. Because we shouldn't still be stepping. Or sorry, we shouldn't be continuing to hit consistent guard positions. Guard positions is getting reset. Looping is set to false every time we find one, right? Yeah. We call reset board every time we get in here. Do you really want to continue to that case after setting looping to true? That's a good question. I don't think it really matters. Unless you can think of a way that it does. Because we're not going to do anything with guard position after that point. So we set looping to true. We don't put the position into the positions, but that's fine because it's already in there. Then we technically compute the next position and set guard position to it. But then after that step runs, we check whether it's on the board. It's always going to be in that case. And then we check if it's looping. And we break out of the loop. Something is very suspicious here. Like it feels like we're leaking some state or something somehow between the different runs. I just can't think of a way that we would be. A/B test the small input. Yeah, people always say that. That's no fun. That's too easy. Yeah, at least we can understand the map. It's true. My code doesn't handle arbitrary. We have to fix stuff in our code to be able to do that, because we have hard-coded numbers. Is that the only one? I mean, I guess we can do a little like input dot lines dot first dot strip dot length -1. Is that right? Yeah, so that's like it's the right answer. So that is okay. So we can temporarily swap out our our solution for the sample one, or our problem for the sample one. Now, assuming that is square. I'm gonna assume that's square. It's always hard to tell with text. And and we'll have to remove our little bug there, or our thing there. So this is 41 and 11, and I think 41 was the right answer for the part 1 for the test input. All right, 41, yeah. But we are now recording 11 rather than 6. I just had a thought. Original guard positions is an array. This needs to remain a set. So we were double counting. I think I even saw that when we were doing this for some of them. Did I? there should be double counts in here. Yeah, look at that, 103.22, 103.22. So there's a double count that we've detected, and that was because as we turned, we would record the same position twice, but in different directions, and we weren't eliminating those. And the crossings. And the crossings, that's a good point, yes. Now just double check whether I need to do something. Set.new 1, 2, 3 minus 1 still is a set. Okay, that's great. All right, so that's still a set. So that doesn't, we don't have to worry about that there. Let's just run this. We're still not getting the right result, but I just want to run it with our new, see what number we get now, and double check that's not no duplicates now. No duplicates now. $43.09. Is that not like the same number we got before? That seems way too high. No, it's lower, but it's still not the right answer. That's still way too high. So I think we've still got a bug that's some kind of leaked state bug or something. Let's print out which of these are actually landing here. So rather than printing this out here, let's print them out here. See what we see. So we are seeing some weird thing. So I guess let's compare to what they said. They've listed 1, 2, 3, 4, 5. They've listed all 6, and I wish they had told us what that is. So that's 3, 6. 3, 6 should appear in here somewhere. 3, 7 is a yes. 3, 6 is a no. Which is very strange. Step debug, yeah, step debug 3, 6. What did I do wrong? This was a curly brace. So 3, okay. So this makes me extremely confident that I am right, that there is some kind of leakage happening here. Because we just tested only 3, 6 and got a yes. What was the other puts there? Where are my other puts? Result 2. Wait, what is printed out here? Why do I have a 3 and a 6 afterwards? We solve part 1, get 41, which is correct. And what's the other 3 and the 6 being printed? Oh, sorry. That's what it is. Used each and yeah, thank you. Okay, so that's fine. So we know that on the first run, it does do the right thing, and that we can arbitrarily put, or not arbitrarily, we can inject a second option that we pull from this list and maybe see it fail. So this is 0, 1, 2, 3, 4, 5, 6. So this is 6. Oh, that's not where that goes. 6, comma 0, 1, 2, 3, 4, 5, 6, 7. 6, comma 7 should also be a yes. Oh, and it gets yes. Interesting. Well, that's very suspicious. But we know, for example, 6, comma 8 shouldn't be a yes, so let's put that in there. And it is a yes. So what? Oh, we're not resetting the obstacles properly. Oh, there it is. Yep. There we go. So that should fix everything. If I just looked a little harder at that, I probably would have got there. I should make a little like progress thing for ones that take a little longer. What's going on here? Why is this taking so long? This is too long, isn't it? I guess we could have tested it against the original input. Ignore that. Here, let's just revert some of our changes. Bring those back, but get rid of this. Okay. So that gets the right answer. And okay. It's relatively slow. We are doing things that are like definitely unnecessarily slow. Like reading the file again every single time we reset the board. So you know we're doing stuff knowingly bad just because we've been too lazy to address those things. That's probably a huge hit on our performance, and I could probably fix that. This seems like a way more conceivably correct. It's number of yeses. I think it's really funny, this thing we were doing by not resetting those obstacles. We were like adding obstacles, and then as we added more obstacles along the path, they weren't doing anything because the first one we had added was causing a loop. I'm going to look at. I missed a bit. Are we brute forcing? No, we ended up with a bit of leaky state as we were trying to reset the board, which was causing a whole bunch of issues. And we used the test input that they used in the problem to sort of work our way down to where that was coming from. And now we're just running it, and it's slow primarily because we are actually reloading the input every single time. Which, how many places do we use the input? We could fix that, but I'm gonna let it run. I'll optimize it afterwards if this is the right result, because this could be much faster than it is here. There's not that many of them because we're iterating over the path that we know of. So we also had a bug because we were checking certain potential positions twice as well, because something wasn't a set. I guess I can look at the optimization now. So input dot lines is used everywhere input is called. We call input dot lines. So let's just handle that here. Dot lines dot map. Strip map chars. And then still running. So now this just input dot first dot length. Change line 22. Yeah, nice. And there's another. Where's the other call to input? Somewhere here we go. Just gonna input. We don't need to map it through strip. Don't need to grab the chars. Cool. That should be adequate. I'm gonna open another one and run it. Yeah. There we go. So we didn't need to pull out Vernier and profile this thing. We identified just through reasoning that reading the file on every iteration was probably going to be really slow. There are probably other, like we are still like parsing it into our data structure every single time. So do I have YJIT? I didn't even try that. We could YJIT this too. Let's see if that's the right answer. We did it. All right. I'm going to kill this one. We don't need to see that finish. Well, we did it. This is the entire solution inside of... we can remove these now. Yeah, I'm curious as to what the one thing, it's like, yeah, short-lived applications aren't going to benefit from a lot, but this one is kind of interesting performance-wise because it's just a bunch of loops doing the same things over and over again. Yeah, lots of iterations, like Marco says. But also, I'm really curious as to how well that the method missing would play into YJIT. Because like, I can time this. Oh, I should remove those. The IO, because we don't need that. Really cache method missing? Probably not. Yeah, I do wonder if we'd see. How do I turn YJIT on? Can I just do it? Enable YJIT. We are using 3.3 here. RubyV shows if I have it. Q. It doesn't say any YJITs. No. Okay. That's an interesting one though. I would be curious to try that out. So maybe I'll look at getting YJIT action on here for a future video, because I recently like pulled Vernier out to debug a production issue and found that it like helped me pin down my production issue in like no time, my performance issue. Literally, like, you had 121 seconds, but I have 29. That's pretty good. And I do think if we end up in some interesting like infinite loop or just like slow performance situations, it would be fun to profile one of these using Vernier. Like I looked at my chat logs with John Hawthorne, and it was like 18 minutes between when I said I need to use Vernier here and when I had the solution, messaged him that it had solved my problem. It was incredibly easy to use. So I want to pull it out for something here. If we get into trouble and need it, we will definitely be using it. So let's commit that. Day 6, part 2. All right. Thanks for your help, Oynak, Marco, and everyone else who lurked on the stream. I saw you in the list of names there. I saw a bunch of faces that or a bunch of names that I recognize. So thanks for coming out and watching for a bit. I think I will be back on tomorrow to stream, but I don't know what time. It's a Saturday. I got time, so if you want to swing by, I'll try and post on my socials when I'm gonna go live. But as usual, thanks everyone for coming out. See y'all later.